SAGE, which stands for Software Agent for Guided Education, is an educational AI-driven application that we've been working on here in the Visualization Lab for the past couple of months. We're hoping to use it for some research opportunities later on in the year. Certainly, I've been using it as a learning exercise. Sage runs in a desktop view or as an extended reality application for the Oculus Quest line of headsets. It should run on anything from a Quest 2 up, but you're going to want a Quest Pro or Quest 3 to really take advantage of it. It works in mixed reality, so the stuff sort of appears in the environment around you. You've got several different ways you can interact with the experience. You can use voice through the headset microphone. There's also a virtual keyboard that you can use to bring up stuff. There's a word tile interface where I can put together a sentence where the word choices are driven by the context of whatever the knowledge base is. So if I have a bunch of stuff about physics loaded up, largely physics things are going to come up in here. This has a lot of information about artificial intelligence, so artificial intelligence stuff is going to come up in here. Could be pretty much anything that I've put in the knowledge base can drive this. But there's multiple different ways that you can put input. It'll respond with a chat message or commands. Sage has got a command structure where the AI can summon prefabs or summon up images. It's even got a structured lesson plan where it will deliver a structured set of information in a particular order. As you're going through one of these lesson plans, you can ask it questions and you can talk about any of the topics in greater detail, or you can just go on to the next topic until it goes all the way through. And Sage is what we're going to be looking at as the use case for this video. So in a typical artificial intelligence application, you've got your front end, which could be like a web page or an application, or it could be a mobile app or whatever. But it's got a variety of different things over here. And then it talks to the foundation model, which is the thing that's actually processing the text and resulting in the chat through an API, application programming interface. This is typically over a network, doesn't necessarily have to be. This could all be running on one machine. But the thing that gives your application behavior, the tone of voice, the personality, the whether or not it can surf the web or read a PDF file, or a lot of the different things that separate one large language model from another is in the front end of the application itself. Your instructions, your user prompt, system prompt, all that stuff gets passed in as part of the message. And this over here has the logic for handling the input back from the foundation model. Now with Sage, I have a framework sort of like this, where I have voice comes in through the microphone, a WAV file goes off to, in this case I'm using OpenAI Whisper. A string comes back where it's the content of that WAV file. Then that gets passed into a message handler where the system prompt, any sort of memory about the conversation, the actual user prompt, which results from this speech to text pass, and the knowledge base all gets bundled up into a message which goes off to Claude. In this case, I'm using Claude. These are all modular, so I could swap out, a different type of speech to text engine. I can swap out a different inference model. I can, all of these different things. This returns back a string of JSON, which is then passed to the response handler system, where I've actually got a bunch of different things. There's a user interface that can react to it. There's an action handler. I've got different avatars that can do different things, and prefabs, images, sounds, whatever we want it to do. If I look at the actual system prompt, this is one of the files that goes into the system prompt here. And it's just a text document. I give it instructions on how to behave, and then I give it instructions on how to format its answers. So I don't want just a text response back. I want a JSON response. So in this case, I'm telling it only respond in this specific JSON structure. So its actual text response comes in as a JSON field called response, where this is the actual chat message that's coming back. And then if there's any action types, then I want it to give the specific action type and then any parameters. This is how Sage does stuff. These commands come back from the large language model inside this JSON. Now, when I'm working with the API, the response is already a JSON document. So what I'm telling it to do is put this JSON object inside of this other JSON object that you would already be sending back. So my system has to be smart enough to parse the JSON inside the JSON. I give it a list of available actions. So I can tell it that, hey, load image is an available action, and these are the available parameters for load image. Same thing with start lesson plan, next lesson segment, list lessons, show prefab, hide prefabs, and then hide all prefabs. The intention is that I could load a prefab on top of another prefab and sort of put them together in a modular format if that's what the lesson plan calls for. Now, in a structured lesson plan, for each of the topics, I may have already predefined commands, and that'll be part of the lesson plan. Or the LLM, the AI that I'm talking to, is perfectly free to decide that, hey, based on the context of what we're currently talking about, maybe it'd be a good idea to bring up this prefab, and it loads up the campus model or whatever. I then give it several different examples of how to put this JSON together in different formats. So a lot of the behavior that we're getting out of the AI is defined in this text document. And then I wrap up by giving it, here's a short list of available resources. So if the conversation starts talking about supervised training, perhaps, I've got an image that kind of shows, or that I want it to come up every time the conversation swings around to supervised training. And it's perfectly free to summon that image if it wants to. I also have several fully fleshed out 3D environments that really show the benefit of having this as a mixed reality sort of thing, because I can bring up entire 3D environments, skyboxes, 3D models, that sort of stuff. So that's how Sage presently works. There is a profound, a crippling design flaw to this whole thing, and fixing that design flaw is kind of the point of this exercise. I've put a lot of thought into thinking about what exactly that flaw is and the approach that I want to take to fix it. But this is a journey that I'm beginning that I have no idea where it's going to go. Looking at some of the important classes that I have in Sage, I have the Claude API Manager that assembles a JSON, parses the JSON response. It coordinates with the other classes, so it's kind of the central hub through which all of this other communication goes. I have an 11 Labs text-to-speech, but I could swap this out for something else. If I were going the OpenAI route and using OpenAI, especially their new Assistance API, a lot of this could be done for me. I wouldn't have to go with different providers for different things. But that approach is kind of part of the exercise for this. Eventually, we're hoping to stand up the AI resources on campus that all of this stuff could just be done on a local network. And we would be providing all of the functionality for this. Going on down the list really quickly, I have the action handler. When the message comes back, the API manager parses out the JSON and sends the actions, if there are any, over to the action handler. The action handler talks to these other things and executes whatever those actions happen to be. So on my roadmap for things that I want to do with Sage in the very near future, I've got a couple of things that I want to address. First of all, latency is a real problem because if I go back to here, every one of these completes before the next one starts. So the voice gets recorded and the WAV file goes off to Whisper, and Whisper sends the string back. That string has to come back before the message can be. I can't skip this. I can just type in whatever my prompt is and skip this first step. But I have to wait for this to come back before I actually get the user prompt that I can put my message together to send that off. I have to wait for this JSON to come back before any of these responses can be handled. And then that string has to go off to text-to-speech, and the WAV file has to come back completely before the avatar starts talking. So there can be 15, 20 seconds of latency between sending in the voice, getting the prompt back, getting the text back, having the user interface update, and have the avatar actually speak the voice. This is a big issue. You don't want to have to wait multiple seconds in order for it to start talking. That's just not a normal conversational thing. It's like you're talking to somebody on the moon. You want that response to be very quick. So that's definitely something that I need to look at. Fortunately, a lot of these APIs provide streaming solutions, which for simplicity's sake and just getting the thing working, I didn't take that approach. So swapping out especially the text to speech, and once again, this is something that both 11 Labs and OpenAI provide. I just need to implement it. Long-term memory. I want it to be able to remember from instance to instance, use case to use case, and maybe across multiple different modules. I want it to remember its interactions, its conversations, things that it picks up from the student. I want it to be able to remember that, so the more you work with it, the longer you work with it, the more it learns about you. And the solution to this is really going to be the same solution as the issue that I've currently got, which is my input token usage. And the solution to that is going to be knowledge management. We'll talk about that more in a second. My input token usage is a crippling issue. And it's because of the system prompt that Sage puts together. So Sage, it sounds like it's really complicated, but I really cut a couple of corners when I'm assembling that message. Right now, the user prompt, all of the instructions, all of the memory of the conversation, and the knowledge base, everything that I want it to know about everything I want it to know anything about, all of that gets bundled up into one system prompt. So if I'm having a conversation with it about, say, meteorology, and I've got a 38 kilobyte text document that covers the specific lesson that I want it to cover, that entire 38K document gets added into the system prompt, which gets added to every message. And that message accumulates because that gets added to every message, and every message gets sort of accumulated into a conversation. So that means not only does this thing start off really big, but it gets bigger with every subsequent message that I'm sending in. That's just not it's not useful. It's not sustainable. I'm seeing a difference several thousand-fold between my input token usage and my output token usage. Developing what I've got right now over the course of 3 weeks, I used roughly 80,000 output tokens and over 3 million input tokens. That's just not sustainable. So what I'm going to implement is something similar to a RAG. You've probably heard different AI companies, different AI providers, designers, talking about a retrieval augmented generation system that is sort of sits alongside of the regular API interface, and it adds, it really adds a lot of efficiency to the system. Basically, what it does is it takes the user prompt, and that goes in as a string, right? So whether I type this in or I speak it in, eventually it gets turned into a string that goes into some sort of process. Right now, I'm thinking that I can do this with a local language model. I've got 8 billion parameter llama running on a high-end workstation in the lab, and it's pretty quick. So I may be able to talk to that across the network and have it do this process, which this process is. I want to send it not just the prompt, but a dictionary of keywords, and I want it to take that prompt and reduce it to keywords, but only using keywords from that available dictionary. So the dictionary is going to be built off of my knowledge base. I'm going to have some sort of structured knowledge base where I have the relationship between different keywords and different blocks of knowledge in that structure. So when this language model sends back the list of keywords that it finds appropriate, then I'm going to have another process that will do a really quick lookup of the knowledge that I'm looking for based off those keywords. So for instance, let's say my user prompt is, tell me about the effect of the sun's radiance on the Earth's weather, for instance. This first step would pass that in, and this may return, say, the keywords of meteorology, Earth, radiance. Maybe that'd be enough. Then this would take those keywords, look up the specific piece of information that pertains to those keywords, and add only that into my system prompt. So my system prompt would actually be a little bit different every time based off of the specific knowledge that I'm looking for. But it should give me a dramatic both improvement in the efficiency in the chat generation off of the foundation, but also a dramatic reduction of my token usage going into it. So eventually what Sage is going to look like, this is the same where I've got voice going out to speech to text, coming back as a string. Then that string is going to turn into I'm going to pass that plus my keyword dictionary off to some other process. This is still to be determined what this is going to be. It'll return back a list of keywords. I'll do a keyword retrieval for the specific knowledge that I'm looking for. Then that goes into my message. Everything else from here down, with the exception of this now specified knowledge instead of my entire knowledge base, everything else from here is the same as it was before. This section right here is what I'm going to try and design with Claude today and maybe implement it. So here's the start of my conversation with Claude. Right off the bat, I need you to act as a skilled and experienced C# programmer with Unity. I have a great deal of faith in your ability as a developer. I'm working with a pretty elaborate project and need your help implementing a new feature. Please don't start writing any code till we have a good understanding of the way the system currently works and the requirements for the new system. I give it some details about Sage, what it does, what it runs on. I make sure to specify that we're going to be developing in an Android environment. This is all going to run on an Oculus Quest 3 headset. So those are considerations it needs to keep in mind. I've attached some core classes from my process. So I'm going to get it to read through it and make sure it understands it. Finally, ask it, do you have any questions? Because this is just the beginning of the conversation. The first thing I'm doing is building a foundation for it to work with. So let's see what Claude has to say about that. Yeah, it always says, oh, this is an intriguing and complex system, blah, blah, blah. You're so smart for coming up with this. Let's see, looking back through this. Yeah, that all looks right. So here is got some questions. What specific new features are you looking for to implement? We'll get to that, Claude. That's a good question. How does the current system handle XR interactions? Are there specific? Yeah, you don't have to worry about that. Are there performance issues or limitations you're currently facing? Yes, 1 in 3. Questions 1 in 3 are what we're here to address. How are the 3D models currently managed, displayed in the VR environment? That's not pertinent to what we're doing today. That system works. Any integration with external educational content or databases beyond the knowledge base files mentioned in the code. So every other question is exactly what we're here to do. Are there any specific areas of the current implementation you feel need improvement or refactoring? Yeah. I gave it a fairly detailed. I think it's detailed. I'm sure I left out a lot of stuff. Um, Detailed information about what I want the new system to work. Basically, the problem is that the system prompt keeps accumulating, snowballing. I don't want to say exponentially exactly, but it's pretty close to exponentially. Uh, I tell it I need a RAG type system. I tell it that I'm working on Android, so I'd like it to run locally on the headset if that's something that we could do. Ideally, I would like this system to be simple enough that somebody putting together a module for Sage would not have to do a lot of stuff in Unity, where the knowledge base, the keyword dictionary, all that stuff is stored in string files that the user can just edit. I do mention that if running on the headset isn't feasible, then we could stand up something on the local network to act as a server for this. So let's see what he says about this. He says he understands the image. The image was helpful. That's good. Pre-process and index a knowledge base. Yes. Create a keyword dictionary for efficient lookup. Implement a local retrieval system on the Oculus Quest or a nearby server. Yep. Integrate the retrieval step into the existing flow. Here's his proposed solution. Parse the existing knowledge base into smaller indexable chunks. Yeah, I'm thinking like a page, right? If I take say I've got 100 pages of knowledge base, and I can take that and break it up into individual pages, and each individual page has a set of keywords associated with it. So the keyword retrieval would bring back one page of data. That one page of data would be included into the knowledge base and hopefully would have a lot of information. The downside of that approach is, what do I do with a topic that spans more than one page? I could have it bring back all the pages. I don't know. We'll think about that. Store this pre-processed data into a format easily accessible on the Quest 2. SQLite database? I've never run SQLite on a Quest. Or a custom binary format. That's interesting. All right, moving on. Keyword dictionary, extract the key terms from the knowledge base, potentially use NLP techniques, TF-IDF, or word embeddings to identify important terms. Store this in a separately, easily searchable structure. Local retrieval system. Implement a lightweight retrieval engine that can run on the Quest 3. I have no idea what BM25. I have no idea what cosine similarity That's okay. I don't have to know. I don't have to know what these things are just yet. Um, Consider using a library like Lucene.net. Add a new step in the pipeline between user input processing and Claude API call. That's correct. Use the user's input to query the local knowledge base, retrieve relevant information, and include only this in the system prompt for Claude. And to implement it, create a knowledge processor class. That's a good name for that class. Local retriever class. That makes sense as well. And then we're going to have to modify the Claude API manager. Boy, something else I should put on the roadmap is refactoring this API manager because it's getting big. And then before sending a request to Claude, query the local retrieval, update the action handler UI manager to accommodate the new flow. That really shouldn't take any work. From the API manager down, that shouldn't be any changes. And then it gives me an outline of a local retriever. So index path, document path, retrieve relevant chunks. Yeah, these little comments right here. Implement keyword extraction logic. Yeah, that's where all the magic happens. So even though I told it not to write any code until we have a handle on the requirements, it can't help but writing some code. At least it didn't put it in an artifact, which we're going to have this conversation until it's ready to start implementing, and then we'll get it to start writing some code. So I want to ask it about my idea about using a smaller language model that I'm not going to be doing any kind of elaborate inference with. He's writing a bunch of stuff. I bet he loves the idea. Absolutely. Using a smaller, faster LLM for keyword extraction is an excellent idea. It's very complimentary. And sometimes I wonder, Claude, is it part of your system prompt to blow smoke at my ass? I mean, this approach can provide more intelligent and context-aware keyword selection compared to simple string matching using basic NLP technologies. Thank you, Claude. I like the idea too. LLM for keyword extraction can use a smaller, efficient model like Llama 2 7B, or even smaller models GPT-2, something small, which can run locally on a Quest 3. And I think this approach is why you see some companies like I can't think of any off the top of my head, but they're still using ChatGTP 3.5 for some of their stuff, and I think it's because what they're asking of the language model is very simple. I'm not asking it to be very smart. I'm asking it to, hey, here's a block of text. Here's some words. Find which words apply to this block of text out of this list. That's all I'm asking it to do. I think that is all right. User input is received. The input and keyword dictionary is sent to the local LLM. LLM returns keywords. Keywords used to query the local knowledge base. Retrieval information is sent to Claude for the final response. Implementation outline. All right. LLM keyword extractor. Okay. Yeah, that should be its own class. The keyword extractor, that should be its own class. Local retriever to use this LLM based keyword extraction. There we go. integrating with the Claude API manager. Yeah, that really shouldn't be that big of a change. Ensure the local LLM is fast enough for real-time interaction. You might need to experiment with different model sizes and quantization techniques. That's a mouthful. Accuracy, test the keyword extraction thoroughly to ensure it's capturing the most relevant keywords. Keyword dictionary, regularly update the keyword dictionary to cover new topics and maintain relevance. Implement a fallback mechanism in case the LLM-based extraction falls or returns no keywords. There's going to be a lot of these where the prompt doesn't result in any keywords coming back. In which case, I would just skip over the next step. We would do no retrieval and just process the prompt as it is. Would you like me to expand on any part of this implementation or discuss how to integrate it further with your existing Sage architecture? So from my next prompt, I tell it, let's break this down into different stages. I don't want to try and tackle the entire system at once. Let's just start with the first step of this process, which is going to be taking the knowledge base and then breaking that down, pre-processing it, extracting keywords out of it, and building a dictionary of keywords that I can index into the knowledge base itself. And then we'll worry about working with the rest of it after we get this system working. So he likes that idea. Absolutely. Focusing on the knowledge base, blah, 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 is a great starting point. Of course it is. And he gives me a class in C#, and this is fine. So this is something that would be done. This actually be done the first time the application loads up. I can have it check the knowledge base, see if this has already been done. It's nice and neat. Don't know how well it works. It looks like it would. I don't know. I have a feeling this would generate garbage. But going on down here, he explains how it all works. I'm only going to be working with ASCII text files. Simple doesn't require any external libraries, generates both an inverted index for quick lookups and a keyword dictionary. That's nice. The output is a format that's easy to read and debug. Wow, this might actually work. I like all of your suggestions for potential improvements. Stop word removal, stemming, implementing implementing a simple stemming algorithm to help reduce the variations of the same word. N-gram generation, where it looks at multiple groups of words to determine the meaning. Weighting, and I give it a note telling it that I have a class that's already in the project that catches all of the console statements and writes them out to a log file. It's really useful in an XR environment to be able to see the console in the actual environment while you're running in the headset. That's what this does. It also writes all that information out to a log file. So if it knows that, then it'll use that to capture specific information. And let's see what it does with. So there we go. There's the code. I don't know why it didn't put it into an artifact. Maybe because I told it not too early on. But so there's my knowledge processor and my knowledge manager class. So now all I got to do is move these over to Unity and see how they work. So before I even get it up and running in Unity, there's a couple issues that I run into. Largely because I didn't give it these details in my when I was talking about the requirements. So I need this to run on both Windows Desktop and on Android, and the knowledge base files are going to be in the streaming assets folder of the project, but I want to write the new files to the application data path. Um, and this is so I don't have to come up with uh, specific specific path locations to read these files from. File management is just easier if I bundle it into the streaming assets path, and the application data path is determined by the project name itself. So I don't have to mess with that. Both of these are easy to work with on both desktop and Android, and they obfuscate this stuff from the casual user a little bit. So you kind of have to know where these things are in order to find them. Not that they're really going to be, that security is really an issue on these files. And maybe I just want to work with the stuff that's generated by it. Anyway, so support for Android and Windows is important. So I had it update the knowledge manager class to accommodate that, and the knowledge processor to update that. And then when I bring them over into Visual Studio, they both work just well. I mean, they compile just fine. There's no compile errors in either one of them, which it's really odd. It's uncommon for the LLM to start generating compile errors. And really, you're really only going to see that. You see that in two situations. One where it's giving you just pieces of code to plant into an existing file, and then that's usually user error on my part. Is I skip a certain part. For instance, if I look at the updated knowledge manager class, right? So it's got a bunch of code. A lot of these are methods that already exist. They're just changed. And no, it's the knowledge processor class that I'm looking for. You're right here. Rest of the methods remain the same, right? This little comment, this is very important because I'm not going to be able to just copy this thing and paste it into the script and have it work, because there's code that I need to save from this previous version, as this tells me right here. Rest of the methods remain the same. This is telling me that those methods that remain the same are not in this block of generated code. So I have to replace the process content method, which I actually think is a new method. Process knowledge base. All of this stuff changes. Some of these stuff down here changes, but there's a block of the code in the middle that doesn't change. So that's up to you, dear reader, to integrate that into the existing code. It's not that hard, really. You just have to pay attention to what you're doing. You can't just blindly copy paste. But anyway, so that works, and that leads me to the next issue. As soon as I run it, I get a directory not found exception. Could not find a part of the path. It's looking in the streaming assets folder. Then it's looking for a folder called knowledge base under streaming assets that doesn't exist. This also was not a requirement that I mentioned, but it's just something that Claude decided. Sometimes when there's gaps in the requirements or little pieces of information that it doesn't know about the code, maybe it's something that I wanted to do, but I neglected to mention it. It'll just make up its own stuff. For instance, I'm going to look in a folder called knowledge base under streaming assets. I didn't tell it that's where it is. It's where it decided to look. So I have a couple options here. First of all, that's just a string. It'd be very easy for me to code and change it. That'd be easy. I could go back over to Claude, tell Claude that I don't want to do it that way, and have it fix its code. That has the benefit of that change being part of the context of the conversation now. If I don't do that, then Claude is going to forever think that the knowledge base files are in a folder called knowledge base. It's not that big of a deal, but it's something that I may have to correct several times if this goes into many more iterations. Another option is for me to actually go into my streaming assets folder, create a new folder here called knowledge base, and then load it up with my actual knowledge files. So I've got this. Here's a knowledge file that I've got, just a text file on artificial intelligence. If I drop that in there, and I'm going to copy it so that the rest of the system doesn't break. So in my knowledge base file, I have my AI knowledge.txt file. So come back over here to Unity, and we'll see how this test works. Now, so I didn't get that error. That's good. Now let's go over to my application data path. So here in App Data, Local Low, SCSU VisLab, Claude Sage AI, Process Knowledge, here are the files that it created. So that looks like just the So, I mean, at least on the surface, without actually implementing something in which to use this, I think it pretty much worked. I mean, it worked, right? There's worked, and then there's works. So I don't know really how well it works yet. I have to implement something to use the system in order to test the system out. Boy, this would be a good use case for unit test to make sure. And maybe they'll do that next. Or maybe I'll just try to implement it into the system. But this seems like a good stopping point. I've been talking, even with all the M's and buts and pauses edited out, this thing is scaring the hell out of an hour. So I think I'm gonna stop this one, and the next video will pick up with implementing the keyword retrieval.